Hello everyone, welcome to our Math 10 classes. Have you ever wondered how outcomes in certain real life could be solved mathematically? What do businessmen use to predict future sales? How do bank executives deal fluctuating rates such that the business does not go bankrupt? Have you, at some point in your life, used numbers to be able to make sound and logical decisions? Consider this question. How can the outcomes of a certain real life problems be predicted? Okay, look at this example. What is the next number? 0, 4, 8, 12, 16, blank. Do you know what is the next number? Yes, that is 20. Why 20? Because as you have noticed that we have to add 4 to get the next number. Like 0 plus 4 is 4. 4 plus 4 is 8. 8 plus 4 is 12. 12 plus 4 is 16. And 16 plus 4 is 20. Now the question is, what is the 10th number? Now, we will define first what is a sequence. A sequence is a function whose domain is a finite set of positive integers or an infinite set. Differentiate a finite or infinite sequence. What is the difference between a finite or infinite sequence? Okay, let's consider this given example again. What is the formula for this sequence? We have the given n, 1, 2, 3, 4, and our a sub n, 4, 7, 10, 13. Now, can you give what is the fifth term? Okay, why is it that the formula for that given sequence is a sub n equals 3n plus 1? Okay, as we have noticed that the given terms are 4, 7, 10, and 13. If we subtract the next term to the previous term, we have 7 minus 4 is 3, 10 minus 7 is 3, and 13 minus 10 is 3. So they have the common difference, which is 3. And if we will check this given formula, we have 3 times n plus 1. We have the value of n are 1, 2, 3, and 4. So 3 times 1 is 3 plus 1 is 4. We can get the first term. We have 3 times 2 is 6 plus 1. That is 7. That's the second term. And 3 times 3 is 9 plus 1. That is 10. That's the third term. And we have 3 times 4 equals 12 plus 1 is 13. And that's the fourth term. So if you have the formula or the general term, you can still get, if you will be asked, what is the 10th term for this sequence? By using the given general term or the given formula. Okay, consider this next example. Find the first 5 terms given the nth term. We have a sub n equals 2n minus 1. So how will you get the first 5 terms just given the nth term or this formula. Okay, we have a sub 1. So we will start with 1 as the first value. Next is 2, 3, 4, and 5 because you're asked to find the first 5 terms. So we will start with a sub 1, which is the first term. So we have 2 times 1. We will substitute 1 to the place of n. So 2 times 1 is 2, minus 1 is 1. Next is a sub 2 or the second term. 2 times 2 equals 4, minus 1 is 3. And the a sub 3, we have 2 times 3 minus 1 is 6 minus 1 equals 5. The fourth term is 2 times 4 minus 1, that is 8 minus 1 equals 7. And the fifth term is 2 times 5 equals 10 minus 1 is 9. So the given sequence or the first 5 terms are 1, 3, 5, 7, and 9. Now, what is an arithmetic sequence? A sequence whose consecutive terms have a common difference. The number d is the common difference in the arithmetic sequence. An arithmetic sequence is a sequence where every term after the first is obtained by adding a constant called the common difference. Okay, let's proceed to this example. If a sub 1 or the first term and d or the common difference are known, it is easy to find any term in an arithmetic sequence by using the rule. So you have to take note of this given formula. We have a sub n equals a sub 1 plus n minus 1 times d. Now we have this next problem. What is the third term of the arithmetic sequence 5, 12, 19, and 26? So there are only 4 terms given, and we have to find the 10th term. So what shall we do? We have to get first what is given. So as we know that a sub 1 or the first term is 5 because that's written at the first term. Next is you're going to find the d or the common difference. You have to subtract the second term from the second term minus the first term. So we have 12 minus 5 is 7. We can have also 19 minus 12 is 7 or 26 minus 19 is 7. So their common difference is 7. And we are going to use the rule or the formula to find any term in an arithmetic sequence. So we have a sub n equals a sub 1 plus n minus 1 times d. So the problem is we're going to get the 10th term. So we have a sub 10 equals 5, which is the first term, plus 10, because our n is 10, because we're going to find the 10th term, minus 1 times 7, which is our d, the common difference. And we're going to solve now. A sub 10 equals 5 plus 10 minus 1 is 9 times 7. A sub 10 equals 5 plus 63 because 9 times 7 is 63. So we have to follow the MDAS rule. We need to solve first the multiplication or division before addition or subtraction. And we will simplify. A sub 10 equals 68 because 5 plus 63 is 68. Now, the 10th term for that given arithmetic sequence is 68. Now, we will go to arithmetic means. Finding a certain number of terms between two given terms of an arithmetic sequence is a common task in studying arithmetic sequences. The terms between any two non-consecutive terms of an arithmetic sequence are known as arithmetic means. Okay, let's proceed to this example. Insert 4 arithmetic means between 5 and 25. So, there are only 2 terms given, the first term and the last term, and we need to insert 4 arithmetic means. Since we are required to insert 4 terms, then there will be 6 terms in all, including the first and the last. So we have let a sub 1 equals 5 because that's the first term, and the a sub 6 is 25 because 25 is the sixth term. We will insert a sub 2, a sub 3, a sub 4, a sub 5 as shown below. Okay, 5, then a sub 2, a sub 3, a sub 4, a sub 5, and 25. Now we will go back to the given rule or formula. We have a sub n equals a sub 1 plus n minus 1 times the d. Since we don't know their common difference because the second, third, fourth, and fifth terms are missing, only the first and the last term is given. So it's hard for us to find their common difference. So we need to find, or we need to solve the d first. So we have a sub n is 25 because the last term is 25 equals the first term, which is a sub 1, that is 5, plus our n is 6 because there are 6 terms, minus 1 times the d. We don't know what is d. That is why we need to solve for it. So we have 25 equals 5. 6 minus 1 is 5 times d. That becomes 5d. And we need to apply subtraction property of equality. We need to subtract 5 both sides of the equation, the left and the right side of the equation. The left is 25 and the right side is 5 plus 5d, and we need to subtract 5 both sides. So we have 25 minus 5 equals 5 minus 5 is 0 plus 5d. So we have 5d at the right side of the equation and 25 minus 5 at the left side of the equation. Now we need to simplify. 25 minus 5 is 20 equals 5d. And we need to find the d. So we still need to apply another property of equality, which is division property of equality. So whatever the numerical coefficient of the given variable should be that number nga, we are going to divide. So 5 is together with d, so we need to divide 5 both sides. So 20 divided by 5 is 4, and 5d divided by 5 is d. Now, we can determine the next 4 terms because we have already the d, or the common difference, which is 4. Now, the question is, what are the 4 arithmetic terms to be inserted in the given 5 and 25? Now, the arithmetic means, or the 4 arithmetic means between 5 and 25 are 9, 13, 17, and 21. Okay, we just add 4. 5 plus 4 is 9, plus 4 is 13, plus 4 is 17, plus 4 is 21, plus 4 is 25. Now we have solved our problem. Okay, now we will go to the sum of the nth term of the arithmetic sequence. Our formula here is S sub n equals n divided by 2 times a sub 1 plus a sub n. So this is the formula for the sum. The S there indicates the sum. Okay, find the sum of the first 10 terms of the arithmetic sequence, 5, 9, 13, and 17. So in this problem, there are only 4 terms given, and we need to find the sum of the first 10 terms. So since there are only 4 terms given, there are 6 terms missing. So how can we solve the sum of the first 10 terms and there are only 4 given? So again, our formula for the sum of the n terms of the given arithmetic sequence, we have S sub n equals n divided by 2 times a sub 1 plus a sub n. Or the other alternative formula is S sub n equals n divided by 2 times a sub 1 plus n minus 1 times the d. Okay. Now we will use the previous formula. We have a sub n equals a sub 1 plus n minus 1 times d. So we have here a sub 10 because there are 10 terms. Our first term is 5, which is the a sub 1. Our n is 10 because there are 10 terms. So 10 minus 1. And our d is 4 because 9 minus 5 is 4, 13 minus 9 is 4, and 17 minus 13 is 4. So our common difference is 4 here. So a sub 10 equals 5 plus 10 minus 1 is 9. 9 times 4 is 36. So 36 plus 5 is 41. And we will substitute it to the given formula. We have S sub 10 equals 10 divided by 2 because our n is 10 times our first term, which is a sub 1, is 5, and our last term, which is a sub n, is 41. So 10 divided by 2 is 5, and 5 plus 41 is 46. So we have 5 times 46 equals 230. If we will use the alternative formula, we have S sub 10 equals 10 divided by 2 times 2 times the first term, which is 5, plus 10 minus 1 times 4. So we have 10 divided by 2 is 5, 2 times 5 is 10, and 10 minus 1 is 9, times 4 is 36. 36 plus 10 is 46. So 5 times 46 is 230. So we have already now the sum of the first 10 terms of the arithmetic sequence, which is 230. So even if not all the terms are given, but we can still solve the sum using the formula for the arithmetic sequence and the sum. The formula for the sum of the arithmetic sequence. Now we have next example here. What is the sum? Find the sum of the first 25 terms of the arithmetic sequence 4, 9, 14, 19, 24. So there are only 5 terms given, and we need to find the sum of the first 25 terms. So there are still 20 terms missing, and how we will solve it. Okay, let's have the solution. The first solution is the alternative formula. We have S sub n equals n over 2 times 2 times a sub 1 plus n minus 1 times the d. So as we know that there are 25 terms that we're going to add, so S sub 25 equals 25 over 2 2 there is constant times the first term is 4 plus our n is 25 minus 1. And our d, or the common difference, is 5 because from the given, 9 minus 4 is 5, 14 minus 9 is 5, 19 minus 14 is 5, and 24 minus 19 is 5. So their common difference is 5. So we have 25 divided by 2. 2 times 4 is 8, and 25 minus 1 is 24 times 5. So we need to multiply first 24 and 5. And the product is 120 plus 8, that is 128. And we need to multiply 128 and 25. The result divided by 2, and that is 1,600. If we will use the other formula, we need to find first the a sub n. So a sub n equals a sub 1 plus n minus 1 times t. Since there are 25 terms, so we have a sub 25 equals our a sub 1, or the first term is 4, plus our n is 25, because there are 25 terms that we're going to add, minus 1. And our common difference is 5, or the d is 5. So 4 plus 25 minus 1 is 24 times 5, and that is 120. So 4 plus 120, that is 124. So our a sub n, or a sub 25, is 120. And we will substitute it to the given formula. We have s sub n equals n over 2 times a sub 1 plus a sub n. So s sub 25 equals 25 over 2 times our first term is 4 and our last term is 124. And we need to solve first those in parentheses. 4 plus 124 is 128 times 25 divided by 2, and that is 1,600. So the sum of the first 25 terms of the arithmetic sequence 4, 9, 14, 19, 24, and so on is 1,600. So those are the given examples. Don't forget, like sequence, God's love for us is infinite. He loves us unconditionally, no matter who we are. I hope you learn lots of things today about arithmetic sequence. God bless.